how to study with colors. If you are new to this channel, kindly subscribe. This channel gives a comprehensive tutorial video on industrial engineering content, and today our focus will be on facility design, and I'll be teaching you how to calculate for the takt time. Takt time is the same as production rate or plant rate, okay, and it is the rate at which operations, processes, parts, components and so on must run in order to meet production goal. Okay, so the formula for takt time is the effective production time all over the total production. Okay, so effective over total production. Now let's solve some example. Let us assume that you need to produce and ship 1,000 units of products from plant in an 8 hours shift. Okay, from plant in an 8-hour shift. 30 minutes for lunch, 10 minutes for break, and 8 minutes for team meetings are allocated during each shift. Furthermore, let us assume that the plant is operating at 90% efficiency. Given the data above, how much time do you need to produce 1 unit of product? We are to find the time to produce 1 unit of product. Okay, that is takt time. Before we proceed solving this, we need to write down our data, and the total production is the total units that we are to produce at the end of the shift. The total shift is 8 hours, okay, 8 hours, and the production time, so we need to change the hours towards time. Okay, that is in terms of minutes, so we call it production time. So it will be 8 hours times 60, because 1 hour is equal to 60. This is basic math, and we are getting production time to be 480 minutes. So if the efficiency of the plant was given as 90%, and we have to calculate for the non-production time, that is the break, the lunch time and team meetings, and 10 minutes is allocated for break, 30 minutes for lunch, and 8 minutes for team meetings. So the total non-production time will be the 10 plus 30 plus 8, and that will give us the 48. Okay, so after we found our total non-production time, we go ahead to find our actual production time, and our actual production time is the total production time minus the non-production time. That is 480 minus 48, and we are getting 432 minutes. Now we have to consider the efficiency of the machines. Okay, and the efficiency was given as 90%. So our effective production time will be the actual time times the efficiency of the machine, and that is 432 times 0.9, and that is the efficiency, the 90%, and we are getting 389 minutes. That is the effective production time. So we can proceed to find our takt time, and takt time is the effective production time over the total production, and that is 389 minutes all total units that we are to produce at the end of the shift, and that is 1,000. So we are getting our takt time to be 0.389 minutes per unit. So this is our takt time. Now we can proceed or go ahead to find our units or parts per minute, and the parts per minute will be 1 over the takt time. Parts per minute is 1 over the takt time. Okay, so therefore every workstations or every machine in the plant will need to produce about 2.6 parts or set of parts per minute. That is after inserting your takt time. So you are going to get 2.6 parts per minute. Now this rate, which is 2.6 parts per minute calculated above, assumes that no scrap parts are produced or no rework time is necessary. Okay, when we talk of scrap percent, scrap, that is rejected products, there might be some defectiveness, okay, when the machine is producing these parts. That is why the efficiency is not 100. Since the efficiency is not 100, then we must also include scrap percent, but the calculated takt time did not involve any scrap percent. Okay, so now let's move on to calculating scrap percent and rework rate. Okay, now the scrap percent is indicated as I. For us to find for the scrap percent, it is the total production or the total units that we have to produce all over like the scrap. Okay, so 1 minus scrap percent 1 times 1 minus scrap percent 2 times 1 minus scrap percent 3, and so on. Let's take some example on the scrap percent, like involving scrap percent, and we will know how to use the formula too. For example, assume the production process has 3% scrap rate, 1000 units, or 4000 units to be produced. So we are using the same constraint as given in the first example, but with this one, the production process has a scrap percent of 3. Okay, so the scrap percent is equal to the total production, that is the total units that we have to produce all over. And since it is 3%, then it means we would have 3, like 1%, 2%, then 3%. So 1 minus 1%, and that is 0.01, times 1 minus 2%, that is 0.02, times 1 minus 3%, that is 0.0. We can input them, is equal to, I will be equal to 1062.6 units. Okay, and we have to round it. Okay, so we are going to get 1063 units. So it means that right now, after inputting our scrap percent, we need to add 63 more units to the 1000 units in order to cover for the scrap percent. So at the end of the shift, we are to have 1063 units, and we believe that 63 of the units will be defective. Okay, 63 units will be defective, and if 63 units are defective, then it means we are still going to get our 1000 units will be shipped. Okay, so we don't have to disappoint our clients. Okay, so it is good or advisable to add scrap percent to your production process, because if you don't add them to your production process, you might end up producing maybe 2 or 3 defective units, which will delay your delivery time, okay, or your lead time. Okay, so now so it means that we are starting with 1063 units, then we can go ahead to find our takt time, okay, using the same preamble. So our takt time will be effective production time or the total production. Okay, so the same preamble, but what will change here is the total production. Now we are not dealing with 1000 anymore, but we are rather dealing with 1063 units, because we are involving scrap percent. Okay, thank you. Therefore, workstation and every machine. So after finding your takt time, we can go on to find our parts per minute. Okay, just like we did for the first example. So we can go on to find for the parts per minute, and we are getting 2.7 parts per minute. Unlike the first one we had 2.6 parts, but with this one we are getting 2.7 parts. It means that the rate at which we are to produce parts will increase, because we have increased our total units.